In this video, we're going to be learning about medians and altitudes in a triangle. The median is actually one of the easiest ones to draw, but its special relationship is a little bit more difficult to understand. First, let's start by understanding what a median is. A median is a line segment that joins a vertex of a triangle and the midpoint of the opposite side of a triangle. So here we're asked to draw the median LO for triangle LMN. So we start at point L, the vertex, and we're going to go to the middle of segment NM. I'm going to put hash marks so that my viewer knows that this is supposed to be the middle. Whether it is or not, I don't know. So that is a median. That's all it takes to draw a median. Find the other two medians of triangle LMN. All right, so we are going to start at N and go to the middle of LM. That is another median. And then we will also start at M and go to the middle of LN. When all the medians are drawn for a triangle, you will find a point of concurrency, and it's called the centroid. Unlike the circumcenter and incenter, the centroid does not have anything to do with circles. It has a different property. The centroid of a triangle is a point that is 2/3 of the distance from the vertices to the midpoint of the opposite side. So when we go from the vertices to the midpoint of the opposite side, that's actually the median itself. The centroid is 2/3 of the way across the median when you're leaving from the vertex. Something that is special about the centroid is that it's the center of gravity or the balancing point for a triangle. So as long as that centroid location is being supported, then the triangle will balance or be stable. So let's talk about the first part again, because that's the more confusing part. For median AD, AG is 2/3 of AD, and that's what this is saying right here. Okay, which means that GD or DG is the remaining 1/3 of AD. So if I broke this into three pieces, if I broke this median into three pieces, I would have 2/3 here, 2 of the 3 there, and then this one is the remaining 1/3. And this applies for all the medians. Say we were talking about median CF, then from C to G is 2/3 of CF, and G to F is the remaining 1/3. What that means is there's also a relationship between GF and CG. And that is 2/3 is twice as much as 1/3. So GF is half of what CG is. GD is half of what GA is. And we can do the same for BE. BG is half of what GE is. And that's what these are saying here. So as long as you can remember that this is 2/3, then you should be able to remember that this is 1/3, and that 2/3 is twice as much as 1/3. So those are the relationships you need to know. Let's take this and apply it. We are told that I, K, and M are midpoints. So this is a midpoint. K is a midpoint. And I is a midpoint. Well, if those are midpoints, then J to M is a median, H to K is a median, and L to I is a median. Since it's a median, that means N is the centroid. Now we are told that JM has a length of 18, and we're asked to find JN. So here's what I'm going to write. Since we know that this is the centroid, JN is actually 2/3 of JM. JN is 2/3 of JM. Now I'm going to fill in some of the numbers. JN is what I don't know. 2/3 of JM, which is 18. Now, some of you may not like fractions. Just keep it as two separate transactions here. We're going to do 18 times 2 divided by 3, or in the reverse order, do 18 divided by 3, which is 6, and then multiply it by 2. JN is 12. Okay, the second part of part A is asking us to find NM. Well, we know that so far that this is 12, and that's 2/3 of JM. So that means that NM is 1/3. Well, we already talked the fact that JN in this case would be 2 times what NM is. I know that says that differently than what's up here. Either you say NM is half of JN, or you say JN is 2 times as much as NM. I don't care which one you go. So JN is 12, 2, and then NM. And if we were going to solve this for NM, we would divide by 2. We find that NM is 6. And some of you probably had that in your head before we even got there. All right, I'm going to erase this 12 because the new scenario may not be true for these distances. So part B. HN. All right, so HN is 14. HN is, and they want us to find NK. What's the relationship between those two? HN is twice as much. HN is 2 times as much as NK. So HN is 14. 2 times, we don't know what NK is. If we divide by 2, we will find what NK is. NK is 7. And then they say, what is HK then? Well, if HN is 14 and NK is 7, we can use segment addition. And we just do 14 plus 7 to find HK. 21 is HK. And that's not the only way to do that. If NK is 1/3, that means I would multiply it by 3 to find HK. So 7 times 3 is 21. You could also do, if HN is 2/3, you could multiply by the reciprocal 3/2 to find out what HK is. But that probably wouldn't have been the most simple way to do that. So just to give you extra practice here, since we did not talk about LI, the median LI, let's say that IN is 5. If IN is 5, then LN must be 10. And if this is 5 and this is 10, then IL would be 15. So just got to know those relationships there for those numbers. Next and final thing to talk about is the altitudes of a triangle. Okay, altitude is nearly synonymous with height. So when we talk about the altitude of a triangle, we are talking about the height of that triangle. I don't have a triangle handy. Give me just a second. So a triangle would actually have three different heights because, if it's laying on this side, then it's this tall. And if it's laying on this side, though, then it's this tall. And if it were laying on this side, now it's this tall. And we always measure height perpendicular to the base. Now, when we draw our altitudes, our triangle might be stuck on our paper in one way, in a certain orientation. And we're just going to have to kind of imagine that we're rotating it around, like I just did with my little manipulative here. Okay, so it may be stuck like this, but we're going to have to think, okay, this is the bottom. Well, then this would be the top, and that's going to be my height. And we measure perpendicularly to the opposite side. We will always go to the vertex because that's going to be the tallest point, no matter which way it's rotated. That's the tallest point. This is the tallest point. This is the tallest point. So make sure that we are going to the vertex, and that's what this description is going to suggest as well. An altitude is a line segment from the vertex, which goes perpendicular to the opposite side. Now, in this case, your altitude is actually just the side of the triangle. That will happen with a right triangle. This altitude, you can see, is not in the center of that side or anything. Whereas this one, because this triangle appears to be isosceles, and so it actually will act as not only the perpendicular bisector of this side, it will also be the angle bisector. It will also be a median. So sometimes one of our segments could be multiple. But this last one is the most interesting. Even though the base of the triangle is here, the altitude needs to drop perpendicular to that side. And so they've extended that side to do so. If I were measuring my height and I were leaning over, it would just drop straight down to the floor. It wouldn't be down my spine if I were curved over. So you just have to understand that even though we wouldn't make it go like this, that's not the height of the triangle. It has to just drop down. Imagine gravity acting on a string. It's going to pull it straight down to the ground. The three altitudes can be drawn to form something called the orthocenter. And there's really not much special about that as far as special properties that go with it. It's just that it's rare for segments to meet all in one spot, and the altitudes will always do that, and they meet at that place called the orthocenter. So there's no relationship otherwise that you need to know. That's an orthocenter on an acute triangle. On a right triangle, the orthocenter is on the triangle. And for this obtuse triangle, the orthocenter lies out here. This one looks a little bit hard to see because the altitudes create other triangles, and it's just hard to tell what the graphic is really saying. So last part of this is that you need to keep all of these things straight, and that's going to be the most difficult part. This is what a perpendicular bisector looks like. When I draw all three of them, which these are the perpendicular bisectors, then we found the circumcenter. And the hash marks indicate to me that the circumcenter is equidistant from the vertices of that triangle. This is what an angle bisector looks like. I can tell that by the arc marks. When I draw three angle bisectors, I meet at a place called the incenter. And this perpendicular marking with the hash marks tells me that Q is equidistant from the sides of the triangle. This is what a median looks like. It starts at a vertex and it goes to the midpoint. Based on those hash marks, I know that that's the middle. When I draw all three medians, I have found the centroid. The centroid is 2/3 of the way across from the vertex to the other side. So if this is 8, then this would be 4, and then the total would be 12. Sometimes the numbers may not be as pretty as that. So like if this were 9, then this would be 4.5, and then the total would be 13.5. So you got to know that relationship. That's definitely the most difficult one to work with as far as numbers go. And then the altitude starts at the vertex, drops perpendicularly to the other side. And when I draw all three of those, like I did here, it meets at a place called the orthocenter. And now I'm going to do my best to help you find a way to remember how we can keep these straight. First thing is that perpendicular bisectors. That's just a really long phrase, and really long words will lead me to the circumcenter. Circumcenter is the longest, just by one letter, but it is the longest of these words. So I associate that with perpendicular bisector, and I've never forgotten it. Angle bisectors. Well, my hint is it's really going to be the only one left. I don't really have a great way of remembering that, but if I use circumcenter, centroid, and orthocenter, well, that's the only one that remains. And then hopefully after a certain point, you do just start to remember these. Medians. Medians, I relate that to meteors. Asteroids, I relate that to centroid, because there are only so many words that end in OID, and that's what I think of. Medians and centroids, it sounds like space terms, meteors and asteroids. And then the altitudes. Altitudes meaning height, so I always think of H. And of the 4 words that are representing points of concurrency, orthocenter is the only one that has an H. And so that's how I remember that one. I know it may seem silly, but if you commit that to memory, it'll definitely help you. But that does conclude the lesson. If you have any questions about how we can apply these things, please let me know.